condition for a light ray to pass undivided, the first condition is that the angle of incidence has to be zero. That means the light has to strike the surface normally. That we have done. The second condition also I explained it, that the refractive index has to be same. If the refractive index of the both the medium is same, then also what will happen, even though the light is striking obliquely, it will pass undivided. Okay, so refractive index same means more or less the medium has to be same, because light and glass and air will obviously have different refractive index. Water will also have different refractive index. So this is by theory. If the refractive index is same, the light will pass undivided. That simply means that both the medium has to be same. If both the medium is water, then the light will pass undivided. Now second one, which is relation between wavelength in the two medium. So till now we know that when the light ray travels from one transparent to the another medium, uh, speed will change, speed of light will change, only frequency will remain, and wavelength will also change. Now we want to know how will wavelength change. Okay, how can we measure the wavelength then? Change in wavelength then. So we have one, suppose this is a transparent medium, light is striking like this, okay, and this is normal and spending like this. So this wavelength is, let's say, lambda, and this new wavelength, let's say, which is lambda prime. Okay, let's say this first medium is the air and second is one medium, it can be any medium. So let's say uh, speed of light in the first medium, which is air, is c, and wavelength is lambda. Then we know the relation, frequency of that light is c by lambda. Frequency of this incident ray is c by lambda. C is the speed of light in air, lambda is the wavelength of that light. And now once it goes to the second medium, the wavelength changes. Let's say lambda prime is the new wavelength. We have to know what is lambda prime. So even though it goes to the another medium, the frequency will remain same. Only the speed and lambda will change. Let's say v is the speed in the second medium and lambda prime is the wavelength of the second medium. So both is same, so we equate this, and from there we get lambda prime equals to v by c equals to lambda. Okay, again we know that c by v is mu, so we can bring it back and we can write it as c by v, which is mu. Mu is the refractive index of the medium. So we can write lambda prime equals to lambda by mu, which is very important relation. So if you know the lambda, wavelength of the incident ray, and if you know the refractive index, we can easily find the lambda prime, the new wavelength, okay, of the light in the second medium, if you know the refractive index. From here, if you see that mu value can be more than 1 also, or less than 1 also, as you've seen there, depending upon the speed of light in that medium, mu value can be 1 greater than 1. So obviously when the light passes from rarer medium to the denser medium, whenever light passes from rarer to the denser medium, the mu value is more. Its wavelength will, if the mu value is more, wavelength will decrease. So whenever the light passes from denser to the rarer medium, mu value will be less. If the mu value will be less, then the wavelength will increase. So whenever the light passes from denser to the rarer medium, the wavelength will increase. So this is one of the important relations between the wavelength in two different media. What are the factors affecting the refractive index of a medium? Okay, first is the nature of the medium. So on the factors affecting the refractive index medium is the nature of the medium. So we can see the medium has its property because of this optical density, or because of the medium has different optical density. Okay, the speed of light in glass is 2 into 10 to the power 8, and whereas the speed of light in water is 2.25. Because of that reason, the refractive index is different. Okay, so this is the nature of the medium itself. As a result, the refractive index will be different. Here, the refractive index of glass is 1.5, but the refractive index of water is 1.3, and this refractive index of glass is more compared to this refractive index of water, because of their nature is different and the velocity is different. Next is physical conditions such as temperature. So temperature will also change the refractive index. With increase in temperature, the speed of light in medium increases, so that the refractive index will also change. Refractive index will decrease. If the speed of light in medium increases, then the refractive index will decrease, because the speed of light in a medium is in the denominator. You know the refractive index is c by b. So V is in the denominator. So if the speed of light is increases by any region, in this case the region is increasing temperature, then the refractive index will decrease, which is very easy. The color or wavelength of light. The speed of light also depends upon the wavelength. Okay, speed of light of all the colors is the same, but in any other transparent medium, oh I'm sorry, the speed of light in any color in vacuum is same. Okay, but as it goes to the under transparent medium, the speed of light will be different. The speed of light is maximum, the speed of red light is maximum, and that violet light is minimum. Therefore, the refractive index of that medium is maximum for violet light. As you know, the refractive index has inverse relation with the speed. So, though the speed of light is maximum for the red light, refractive index is minimum for the red light and maximum for the violet light. So, the wavelength of the visible light increases from the violet to the red end. So, we know the visible region extends from violet to the visible region range is in the mid way between this red and violet. So wavelength will increase from the violet to the red end, and the refractive index of the video will decrease with the increase in the wavelength. I think this is also easy. The principle of reversibility of this next.